So this is exciting. We are finally going to be validating if our idea for the rendering machine over there is gonna work, but first, we need a long Ethernet cable. So, all right, so one of the few pieces of the puzzle still, well, there's a few pieces of the puzzle still missing. Okay, one of the pieces of the puzzle still missing is getting a 10 gigabit Ethernet connection to that machine. So we've swapped out to the Supermicro board that doesn't have it on board, but the good news is, oh, I just dropped one. Okay, well, the good news is my X540s and other 10 gigabit cards are here now. So we're gonna go ahead and get that puppy linked up. Then we have to actually build the machine. I've just had it in a test bench up till now, so. This was the thinking behind the carabiners in the ceiling. Okay. So now in theory, we are 10 gigabit. Sick! All right, we're good. So let's actually build this machine. Finally. Okay, so I thought that this RPC 4224 was actually going to be one for us to grow into, but it looks like we need it now. So this is the last of my 4U cases from Norco that they graciously provided for our new server room. And we are going to be using this one for the rendering machine. So there's all of our mounting hardwares. There's our nice soft foam that my cat would eat if he could get at it. And he would try to swallow it, and he would then get it stuck in his stomach, which he did again, costing me another $1,200. If he does it again, I'm gonna kill him. That's twice in 4 months he's eaten foam and needed surgery. So there.
Point, is it cheaper to just get a new cat?
It would have been cheaper to get 2 new cats the first time. Now I could have had 3 new cats and like a pretty cool lizard. But he's my baby and I love him. That's what I tell myself. It's like, gee, why doesn't Linus have a Lambo with all that YouTube money? Because he has the world's most expensive cat. That's why. Okay. I'm gonna need a minute to clear some space here, I think. And machine gun. Power supply. Now I could leave the 860i that I have in there, but then if I ever want to actually put graphics cards in, because I'm going to take those graphics cards out, if I ever wanted to put proper graphics cards in, then I would have to replace it with something else, which is kind of a pain in the butt. So, you know what? No, I'm gonna stick with the 860i. The odds of throwing graphics cards in here are pretty slim. Do you know how long it's been since I've seen a motherboard where I actually have to pop the covers on the I/O plate off myself? Like, are you for real? YOLO, man. Oh, that's really tight. Okay, I need pliers. Okay, just doing a quick test fit here, finding out where the devil all the holes are. So that one over there and this one right here. What? Okay, so there's that one. There's that one, there's that one. Where's this one?
Do you need all of them?
Well, it's optimal.
Get away with 2, I think. That's what I do.
This show is all about the right way to do things, so...
It's at least 3.
I guess we'll need a power supply at some point. Okay. And, oh, look at that! There's fan headers over at the front here. It's perfect. It's like Christmas.
Kind of a weak Christmas.
A fan header?
Yeah.
Your expectations are so high. How did you know that I wasn't going to do fan headers for Christmas bonuses this year? Now my feelings are hurt.
They should be.
Now that my feelings are hurt, maybe there'll be no Christmas bonus. Did you ever think of that? Bet you'd rather have a fan header than nothing.
No, I think I'd rather nothing than fan headers, just because that's kind of insulting.
Duly noted.
Merry Christmas, everyone. Here's poop. Oh, you don't like poop?
Oh, you want poop?
Nothing?
I think everyone in the comments will agree with me that fan headers are better than poop.
That doesn't even make sense. At least you could use poop.
For what? Leaving on your boss's desk for giving you fan headers?
Bosses who give you poop.
I actually ordered a game with little turds and Velcro helmets that you wear that they stick to on Amazon that I was thinking we'd play on channel. Super fun. So it occurs to me now, I need a graphics card. I didn't really want to put one in here, but this motherboard has no onboard graphics. And you're sure you can't use a Titan. So I'm thinking as I install the power supply, this is the one piece of hardware in this machine that I would really like to change. Not because the 860 watt isn't enough for what we're gonna do. And that may be the case in the future if we find some kind of application that can take advantage of GPU, which is why I wanted a motherboard in the first place that would support multiple GPUs. But the reason I would like to have a different power supply in here is actually more to do with redundancy. But finding a mini redundant, so that's what they're called, a mini redundant power supply, one in this form factor, of sufficient wattage for this system with a couple of high power GPUs, actually not easy. There was a 600 watt, there may be something higher than that. Feel free to leave a message in the comments if you guys can find something better than that. But yeah, I'm pretty much stuck with a single non-redundant power supply. The good news is this is a very reliable power supply, and this machine won't actually be storing anything mission critical. Data goes onto another server, gets ripped off of it, and then transcoded over to another server by this one. It never actually touches the data, so it should be fine. It's just I would rather it was actually redundant, and it'll be on a UPS as well. So the power supply would have to fail to take it down even temporarily. I guess it's all right. All right, in theory, this boots now. Anytime. Hey, all right. Okay, so here we are. Here's our 72 CPU threads, only half of which are actual cores. Weak sauce, I know. And this, my friends, is the reason for some of the confusion around this particular system. Had a lot of people asking things like, why do you need so many CPU cores? To which I replied, nothing, because I wasn't really ready to talk about what the solution was yet. The reason we need so many CPU cores is we're going to be using it for transcoding and then doing the final outputs of our videos to make our videos easier to work on our workstations without lag as we're scrubbing through the timeline, and to make our exports more seamless of the finished videos and hopefully faster. Question number 2, Linus, why aren't you running Linux on a server? It's a server. To which my reply is, well, gee, I guess if you'd maybe asked what software we were using, I might have been able to reply that the software we're using doesn't run on Linux. And in fact, there isn't a Linux version. So we're going to be using Sorensen Squeeze Server. And how this works is pretty much,
It's not server.
This isn't server? Well, where's server? we are going to be using Sorensen Squeeze Server. And the way that works is we pretty much have a watch folder that we drop files into and it transcodes them for us. So we had to do a fair bit of experimentation. By we, I mean Ed, who's behind the camera, had to do a fair bit of experimentation to find out exactly how much we could get out of our 36 CPU cores. And if we did, would it even do anything positive for our workflow? So the exact workflow is not 100% finalized yet, but what we do know is that if we use encode and watch folders, and we set ourselves up a watch folder and a destination, when we ingest footage off of our cards, which will be over Thunderbolt, so we'll actually be able to ingest very quickly, even off multiple cards, automatically our watch folder is gonna take those and apply a particular preset to them. So we can take a big whack of footage, which we've actually got on the local disk here, and then we are going to copy here. And what this will do two things. So number one, it will take the footage off of our SD cards, which we would cut paste instead of copy pasting. And then number two, now that it's safely on our storage array, it will take these and transcode them to a different, easier to work with format and then boot them out somewhere else. So in this case, we are using another local folder, which, oops, I just paused that, which may end up being a bottleneck, but we'll do a quick experiment before this video is over to find out if our 10 gigabit network is gonna benefit us here. What we're waiting for now as the files copy is we've set up our watch folder to monitor itself every 1 minute and then start processing. So we can have a look at our current jobs. Nothing has happened yet, but we'll know soon enough because our CPU is gonna start going bananas here. Oh, here we go. I think something's happening. 5%, 7% CPU. Let's see if the job is showing up. Yep, there we go. So you can see it's taking all of these clips and importing them, then transcoding them, then it does something else. And there's a lot of waiting involved, but our CPU usage should start to slowly ramp up as more of them get past the importing stage and make it to the encoding stage. Excuse me, transcoding, which I guess is also encoding. 76. Oh, it's going up to 85%. Oh, now it's working? Well, what the Sam heck? I guess it just takes a while to get all fired up or something. Look at it go. We're actually getting a fairly reasonable turbo frequency out of this whole process, like 2.7 plus gigahertz right now. So there's actually a couple of different views we can get of this. It looks like CPU 0 is getting most of the love, but we can actually change it to look at the two different NUMA nodes. And you can see that CPU 0's utilization is higher, but it's not that much. Well, it is quite a bit higher. So it is significantly higher than node 1. And then we can also change the graph to overall utilization. So you can see as it climbs really high, CPU 1 kind of catches up to 0, but it is significantly lower. None of these jobs are finished. They're all at the importing or transcoding stage still. It's very interesting. Okay, so we're only seeing like max, highest peak, 70% CPU utilization. And we realized that the last time we validated any of this, it was actually in this server with one of the processors plugged into the motherboard. So maybe the advantage that this one has over the one we're using now is much, much faster storage. So if we can connect to this one over the network, then we should be able to leverage that storage, in theory. So let's fire up the 24 SSD server and see if using that as a target helps. 1 gigabyte per second over the network. And what's interesting about being able to see network utilization here is that unlike local disk utilization, we know where the hard cap is, and it gives us a really clear idea of how much CPU utilization corresponds to how much network utilization. You can see network is actually not even changing in spite of the fact that CPU's gone from 13 to 45%. But what remains to be seen is whether our CPU usage will go higher than it was able to before with less of a storage bottleneck. So like so many of our videos, this one ends up actually raising more questions than it answers, but hopefully we were at least able to answer the question of why we wanted such a high-powered server. It's to enable a smoother workflow when multiple people are hitting the files at the same time, and in order to have an easy, quick way to replicate our data as soon as we ingest it onto our server, so we can avoid the current workflow, which is just leave it on the SD card just in case, because there's only one copy on the server. This way, we'll actually have a copy on one server and a copy on another one as soon as we've ingested the footage and it has gone through this transcoding process. So thanks for coming along for the ride, you guys. If you disliked the video, I think you know what to do, but if you liked it, then go ahead and press that like button. It helps us out a lot, and get subscribed and all that good stuff. If you really liked it, then you can go ahead and check out the links in the video description where you can buy a t-shirt, give us a monthly contribution, or change your Amazon bookmark to one with our affiliate code. That helps us out a lot. And I guess that's pretty much it. Thanks again for watching, and if you are looking for something else to watch after having done all that stuff, then go ahead and click the little eye in the top right corner and check out the video on channel Super Fun that we did, where a certain Terran Van Hemert and an electrical vehicle and some thug life involved.
I don't think that's how you hold it. You should probably have both. Yeah, there you go. I don't know what I'm doing.